Hi, everybody. Dr. Debunk here, doing another session on medical health and wellness, debunking myths, garbage, and crap spread by doctors and other health professionals. I've been doing a little series on the major attributes of human health and wellness from the perspective of theories of aging. And so, just as a quick reminder, currently there's about 10 theories that compromise the science about human health. How do you have maximum motivation, energy, endurance, and strength, both mentally and physically, at all decades of life? What we just generally call high quality of life. And there's all these different attempts in human health science to quantify it. But I like these theories. There's 10 right now. It's not all inclusive. There'll someday be 11. And I've already done 2 of these theories. I gave quick overviews of the inflammatory theory of aging and the circulatory theory of aging. And you should go look at those. Excuse me. Not in any particular order, but they all contribute, as I've mentioned, to you're either having health or not having health. My allergies. Going at it. So anyway, and so it goes like this. The rate at which you lose circulation is the rate at which you're going to age and die. And the rate at which you lose circulation to the organs of your body is the rate at which they will be predisposed to disease. And the other videos go a little more in depth. And so I've done those 2. And so, not in any particular order, today I'm going to do the genetic theory of aging. And so that says your genetics determines, to a degree, the speed of aging and the speed of your predisposition towards disease. So the rate of change of your genetics has a big role there. And the problem with human genetics, it just keeps getting more vastly complicated, more than ever before. I'm not even really that up on it, in little bits. And genetics is broken down into multiple fields. But it's basically saying that our genes play a role in aging and disease, obviously. And it's changing exponentially fast. So there's different ways to break down genetics as it's related to human beings. This model says there's 6 fields of genetics. And so I'll briefly mention them, and then I'll just talk about the ones that are mostly relevant to medicine. So obviously the first one will be medical genetics. What are the medical implications for human genetics? And there's a bunch there. We'll circle back to that. But basically the most obvious one is, the medical genetics for testing of disease, but also conditions. And so, but anyway, we'll come back to that. And then there's another aspect of human genetics that has to do with the behavioral effects, so that our genes determine in part our behavior. They don't make us behave a way, but it's clear as we fully decode the human genome and the commands. And let me back up on that. So there's, and I could be wrong on this now, I'm not up on genes form these alleles, and a gene allele is basically a command structure. It's a bunch of genetic information that's going to cause something to happen. So the formation of your organs, the formation of enzymes, and I think there's probably about 500,000 gene commands, but it's more complicated because they interact. So there's probably billions of gene alleles effectively to produce a human being, to build your genetic structure. Okay, and so, but part of our structure will determine function when you talk about the mental traits of human beings. So in other words, an example would be, how easy is it for you to be angry? Now, there's no question, you see that if if a man and a woman get married and they both have problems with anger, well, it's very likely their children will have issues with anger. Now, part of that's learned, but there's genetic influences here. So, in other words, if there's 10 genes that determine your level of angriness, in other words, people react differently to how easy it is for them to get angry. So, you're bugging me with your attitudes, and how easily do I get angered, and what level of anger do I go to? Well, there's a genetic component. And then, but obviously a dominant one is the environment, but there's without a doubt that if you have more genes that make it easier for you to be angry, then you need a lesser stimulant for you to light your fuse to go haywire. And conversely, other people could have very little genetic predisposition. And so genetics do play a role in all these common human emotions and even traits of how we process things, problem solving, logic. Anyway, so that's that one, just as an introduction. And then there's also population genetics, and that is these genetic traits we see running in populations, and that's related to medicine, obviously, and how you would effectively treat the variations in populations based on genetics. And then that's 3 of them. The fourth one would be the cytogenetics or cellular genetics. How our gene makeup affects cell function. Because humans are just a big walking glob of 40 trillion cells. And the cells form organs, but we have 40 trillion. And so it's a huge field. And then there's molecular genetics, and molecular genetics is just study that, how genes affect the molecules of our body. And that is both at a what we call cell molecular level and a biochemical level. The function of humans is broken down 3 ways: physiology, cell molecular, and biochemistry. So the genetics of this kind of encompasses both cell molecular biology and biochemistry together. That's not really important for this discussion, and then the final area of human genetics is epigenetics, and that's how our lifestyle alters our genetic structure. And that's probably the newest field, which I didn't even believe was real back. I don't know. I'm not sure when epigenetics started. I doubt if it's over 25 years old. But basically, before epigenetics, the concept was your DNA is set. Your genes are what they are. And the body can repair damaged ones, and then they're being damaged by lifestyle. But the idea that your behavior would alter your genetics in normal ways is a relatively new concept. And so what does that mean in practical sense? It means that if you're 18 years old and you and your wife make a baby, you give them genetics. Half of it comes from the husband, half from the woman, the wife. But when you're 50 years old, let's say, and you made a baby, both husband and wife, maybe she's 48 still, and has the accidental oops baby, you're giving a different set of genes. Your genes have changed, both for good and for bad, but lifestyle affects genetics. And now, and I don't know anything about this, but I've just read it, that they believe now that your life experiences, your memories, can be encoded into the genes. So you actually can give memories to your children from your life. Now, I don't know the magnitude of that, but before we even understood genetics at all, back 100 years ago, excuse me, stupid allergies. they believed that this was normal. This was how it worked. That, if a husband and wife uh, both did some kind of construction labor, that their children would be construction workers too, because the memories of the parents would be given to the children. And so they would tend towards the same thing. And then modern science came along. It's like, oh, no, it's genetic. But it turns out that there is some ability of that. Anyway, those are the 6 fields as an introduction. Now, the one that obviously I'm interested in mostly is medical genetics. How genetics affects our clinical lives. Because, I'm a scientist, but I'm, basically a practicing physician. And so what does that mean? What am I doing this for? Just for academic fun because you like this stuff? No, because of how it affects your life, and understanding you can make choices that will affect your genetics, and that's what this is going to get to. So, which would be the practical application. So, the first and most obvious practical application of medical genetics is the testing for disease or predisposition towards disease. So as we keep understanding more gene commands, you can do more and more testing on your genetics to see what areas you're predisposed to versus what you're not. In other words, how resistant are you towards alcoholic cirrhosis? How sensitive are you to getting congestive heart failure? So a very simplified way to get this is, let's talk about lung cancer. So there's going to be genetics or gene alleles that make you resistant to get lung cancer. And then on the other side, there's going to be genetic gene alleles or gene sites that make it easier for you to get lung cancer. And so let's say you have 9 of the resistor genes that make it hard for you to get lung cancer. Your body's just good at dealing with the damaging toxic effects of smoking, because that is the main cause of lung cancer. And you only have 1 promoter. So that means you would get away with a lot more smoking of cigarettes before you would ever get cancer. I mean, essentially, if you lived long enough and you smoked long enough, you would get lung cancer. It's just going to do it. You're breathing fire. All this chemical residue, it's destroying your immune system's ability to keep you from getting cancer. But it would be a lot harder if you have 9 resistor genes and 1 promoter. So the opposite is true. If you have 9 promoters and only 1 resistor, I mean, you might smoke for 10 years, and at 32 years old, 35 years old, you get diagnosed with lung cancer because you can't take the damage it's causing. Now, everything is like that. Every disease condition, personality traits, everything with the other fields, it's all there. So the big thing is as genetics comes along, and we can do it right now. There's thousands of genes you can be tested for. You can go online and get this done. I think it's premature, and we'll get to that. But and so the practical application really is all these borderline genetic conditions, but then the obvious ones. So let me give you an example. So there has to be significant genetics for your ability to succumb to cirrhosis of the liver from drinking excessive alcohol. There's got to be a bunch of genes, because there's a subcondition we've already seen in clinical medicine, and I don't know if they've found any of the genes for it yet. But what that means is, how predisposed are you to alcohol destroying your liver? How long does it take for you to drink enough booze to kill your liver with cirrhosis, and then that'll kill you? Well, we kind of know that number because we've been studying alcoholism and drinking for a long time. I probably mentioned this in another video, but it's called pint years. It's how long does it take for you to drink enough booze to kill your liver? Well, it takes anywhere from 15 to 20 years and drinking a half a pint to a pint of whiskey every day. So if you drink So that's a big variability. So that means this: if you drink a half a pint of whiskey every day, starting in your 30s, you could get alcoholic cirrhosis in 15 years. And that's still a lot of booze, a half a pint every day. But another person who's very resistant could drink a whole pint and take 20 years. So that's over double the capacity. So, well, that's a genetic thing, you know. And so, and that's fine. And I try to explain that to patients and help them when they're drinking way too much booze. But, eventually you would get there, even if you drank a wine. But, 2 glasses of wine every day, it'll take you 100 years or something to get to that much booze. But there's a subpopulation of males, and I don't know how much, I'm not real up on this. This is like 10 years old, this information. But the subpopulation of males have 1/10 the capacity to metabolize alcohol. So it speeds up this cirrhosis problem at a factor of 10 at least. So that means they drink heavy for 2 or 3 years and go into rapid onset cirrhosis and die. And in 40 years, as a doctor, I've had 2 of these people. That's catastrophic. They're normal and they start drinking heavy because life sucks or whatever. And within 2 to 3 years, they get sick very quickly. Over a month, they become jaundiced. They're very sick. They have liver pain, and they go see the doctor because they've never had to see the doctor really. And they're told, your liver's toast. It's cirrhotic. You're all messed up. And why it happens so fast, that's another topic and discussion. But the human body, every organ in your body is like a dam of water. And the dam can be slowly eroded away or damaged, or the dam can be very quickly. But it basically stays intact, and then finally, one year, there's just overfilling the dam, and it just breaks. And once it breaks, it just floods. And that's how it can be. We're normal, we're kind of fine, and then over 6 months to a year, you just decompose. And we see this over and over again in medicine with disease. And so there's not time to react. Well, this condition, which is driven by genetics, is severe that way, how fast. And so here's why genetics means so much. When these genes are understood, when you have these variant genes that make it where you can only metabolize 1/10 the alcohol that a normal person can over the course of their life, babies will be born, and it'll be one of the genetic testing sequences they do. And then they could tell the mom, oh, this is the worst case scenario. Your kid can't metabolize alcohol very effectively. So what does that mean? Your kid never gets alcohol. Not in cough syrup, not rubbing alcohol, not in their skin. They don't breathe it. You don't get anywhere near it. Because we have to be able to break down alcohol. It's a byproduct of metabolism, even if you don't drink. But the point is, even the human body has so much redundancy that even if you are one of these people and you never drank booze and you never got it anywhere, you were hypersensitive to making sure you never got it, you could live a full life because we have 10 times the capacity. And so the value is that person who would normally die from alcoholic cirrhosis under 40 years old would now know that it's like poison. It's like really bad poison. And so theoretically, they could live a full life, 90 years old, 100 even maybe, even though they're essentially genetically broken when it comes to this. That's the value of genetics. If I know your gene makeup and I know your life, I can tell you outcomes. We can tell you within 6 months of when you're going to get cancer or heart disease or whatever, skin cancer here or there. Even more accurate with time. With AI computers tuned to this, with full genetics and a detailed understanding of your lifestyle and the complexities of everything you did. And that's how it's valuable. The rate of decay of your body based on your genetics is a huge thing. It's so valuable. And it's $1 trillion business in the future or more. And I'll get to how that works. Because of this is why you don't get genetically tested publicly. Anyway, But the genetic testing of disease, it's here already. The problem I have is the reason I'm not so pro on people getting a lot of genetic testing is because we don't really know what they mean. We don't have enough information. We're talking like we do, and there's a whole bunch of tests. I mean, it depends on how much money you want to spend. You want to spend $5,000? You can go get $5,000 worth of genetic testing, and the computer will analyze it for you and tell you some of what it means. But really, we've seen with the MTHFR gene that it's not really good enough yet. So the MTHFR gene, that's the methylfolate gene thing. Many of you have heard of this. So we have to take folic acid, which is a B vitamin, and we have to methylate it, and then it's active, and it does its thing. And the B vitamins or metabolic vitamins, they do a lot of stuff. And a while ago, they found this gene variation where you had a hard time methylating folate. And so the consequences would be severe if you can't make enough active folic acid. And so I don't know the history, but it took off, and some company or more than one came up with this. It's not a drug, but it's folic acid that's already methylated. And so they made a prescription, and it went wild through medicine, and we were giving it to people. You would get the MTHFR gene. You would get it, and if you had the variant, then you'd have to go on this. And that sounds great. It's a great fix. But now I've just been looking at some of the newer studies, and this isn't absolute. I'd have to do more data crunching on the medical studies. But what I read as a review study was saying that, they've made a big deal out of this, but this variant isn't as bad as they made it out to be. That most people will have a 20 or 30% reduction in methylation. So you could just take, a significant supplement of folic acid and you'd be fine. But then, wait a second, where did all this hubbub come from? And that's where the corruption comes in. That's where it's very likely the people that were first making this prescription vitamin analog, it's not really a vitamin because it's not how we make them, the methylated folate that they made, they spent the money to get doctors to believe that you have to take this product, that you can't just take a bunch of folic acid, which, because of who I am, I've always pushed people in. So I was having people take high dose sublingual folate, and I seemed to get the same results. So I was like, I never really thought about it, but now, because of all the corruption and the reality, that it's very likely the dangers of this have been overstated, which isn't bad because you're taking a natural substance, essentially, methylated folic acid. But really, if you can just take, 3 times the RDA of a sublingual folate and get the same effect, then why do you have to pay for a prescription? And so my point is, it takes quite a while, a decade, to really understand a problem when we first realize it's a problem. And so this is filled in genetics. They have all these genes, and even if they have some ideas of what they do, we really don't know what they do because they're interacting with all these other genes. See, it's a genetic thing is logarithmic, which I'll get to in a second when we talk about pharmacogenetics. And so it's really valuable, but I think it's premature. And eventually I'll do a video on telling you how to do genetics and what genes I think are important, at least the ones that I can get time to study. It's a vast field. And anyway, so that's the genetic testing thing. The next area of human health and medicine, genetics, is the genetics of change, of behavior, how our behavior affects genes. And it does. And I mentioned that briefly, but without a doubt, your behavior now we see can affect your genetic structure. In other words, you can change your genetic structure to a degree. Now, how deep and how far that goes, I don't know. I'm not up on it. But just the fact that that happens is something relatively new, maybe 10 years old. And so that will be another thing. I won't get into any more of it than that. But the thing I do want to mention more precisely is, 25 minutes, is pharmacogenetics or pharmacogenomics. It's how our genes affect what drugs we should take or not take. And simply put, it works like this. Oversimplification, but you can be a normal metabolizer of a drug. You can be a hypermetabolizer of a drug. That means you get rid of it quick, or you can get rid of it slow. And so depending on what you are, it determines whether you should be on that drug at all, or the doctor needs to be aware. And this becomes critical with age because you have people in their 60s and older on 5 to 10 medications that all interact. And so we see massive side effects when people are on drugs they're not really suited to be on. And pharmacogenomics is how we know. And that's near and dear to me because I'm the medical director of a small lab that does pharmacogenetic testing. And that's a whole thing. But it's really valuable because of how drugs interact. It's a drug-gene interaction, but really it's a drug-gene interaction. Because you could say drug A, let's say you metabolize it normally, but then you take drug B, and because of your genetics, that is going to now take the first drug A and make you a hypermetabolizer, which means it'll go out of your body faster and you won't you won't get the effect. And we see this in nursing homes all the time, where they're estimating up almost 10% of admissions to the hospital are from drug-gene interaction from patients in the nursing home. And I don't know if that makes sense, but it's more of a logarithmic thing, and because there's variants of drug-gene interaction. And so somebody want to be on the phone. But it's critical with age, and it's a growing field. It's expensive, but it's valuable. I'll probably start doing it more in my practice next year. Well, I guess kind of this year. But anyway, those are the main things of genetics that are important to understand. And the big picture, well, the most important thing really of doing this whole video is, well, okay, I can't really do anything about my genetics, doc. I can live healthy lifestyle, which you say will help my genes be better, and that's true. You know, our body, where the genes live inside our nucleus, the nucleus of the cell, the chromosomes are in there. That's like a little world. It's like a city into itself. And we realize now that we're always trying to repair our genes, are being damaged. We're all born with birth defects. Everybody's born with the birth defects. But the ones that your body can correct over the first years of your life, essentially mean that it doesn't matter the birth defects. It's the ones that you can't correct. And that's why somebody who's 18 gets leukemia. Well, that's a genetic problem that your body couldn't overcome. But here's why it's critical. So because of everything I've said, the value of our genes is tremendous. They're valuable as a retail product. And what do I mean by that? It means organ donating is the big thing that comes to mind here. So my genetics are not valuable because I'm an old buzzard. But a 22-year-old, your genes are extremely important because they make your organs, and your organs can be valuable, extremely valuable. And so for those of you who don't know, the Chinese Communist Party in China decided it'd be great to create a criminal enterprise of harvesting and selling organs on the open market. And this is all coming out. It's in multiple news sources. Um, it's coming from the people, the doctors that have escaped China. But there's that religious group in China, the Hong Fao something. I'm probably butchering their name. It's like 20 million fundamental Chinese, and they live simple lives, farming. They don't participate in communism. Well, that's a no-no, and the communists are not nice. So apparently they have genetically typed most of them, millions and millions of people. And so their organs are basically for sale on the open market. And that's a whole story thing. I'll probably do something on it. But the point is, you know, your genetic data is valuable when you're young. So here's how it works. They have, organ donating services all over the world. They have the main one for the US and Europe, whatever. But getting a match, the closer the match, the better it is. So here's the dilemma. These companies like Ancestry and 23andMe, it doesn't appear to me that they're really caring at all about your ancestry. What they're doing is collecting your DNA and having it now on a database that's accessible. And so if you think your genetic data is being kept private, you're foolish. Just like if you think your medical record's private, give me a joke. Privacy doesn't exist anymore in the modern world. And so here's the danger. If you're a multi-billionaire, even multi-millionaire, and your son, is whatever age and needs a liver transplant, well, he could get on the transplant list, but if there's no available donors and the line is very long, he could die before he could get a liver. Even now where you can just use pieces of liver. Kidneys, same thing. But if you had access to the, private databases, and you were foolish enough to get your DNA sampled by Ancestry or 23andMe, well, that could be accessed. That could be bought for a price. Everything's for sale. And so what if your son is a perfect match for the billionaire's son who's destroyed his liver with booze and drugs and coke and everything else? Well, do you think your son's safe? Do you think these ultra billionaires who could care less about us, who think we're cockroaches? I mean, if you think there's nice billionaires, you're delusional. There might be a few. I can think of one. It's no secret. I like Trump as a president because he's a businessman and we need a businessman to run the country. Everything else about him, whatever. But the point is, I think he is a true patriot. But other than him, I don't like the way I've ever heard any billionaire talk, and especially the really rich ones. They're scary to me. Bill Gates is scary. He talks like a sociopathic narcissist. So, what are these people capable of? To save their son's life? You think they wouldn't take yours? And you can, call me crazy, but I say a bunch of so-called crazy stuff like this. But a conspiracy theory is only when it's a theory, when the evidence shows that it's true, like what with the COVID vaccine. It's no longer a conspiracy anymore. It's the reality. The vaccine's broken and it should be off the market, but it's a cash cow, so it's never going anywhere. Like everything else. All the idiotic wars we fought in. Just name a subject, and I shouldn't have to convince any of you that money runs everything. At the root of all evil is money, and it's down there. And so you have $1 trillion business of organ harvesting and donating, and people that are ultra rich. Sorry, they've made it clear we're cockroaches, and they don't care. And so my point is, do not get publicly genetically tested. And that means you don't let your doctor do it. You don't go to a place and do it. And so this is a very long video, but hang in there because now I'm going to tell you the most important thing. If you want to get genetically testing, you have to do it privately. You have to do it anonymously. And basically it goes like this. You go buy a burner credit card and you pay cash for it. You make the concerted effort to stay private. And you use that credit card and you go on the internet as James Smith or John Doe or Mary Smith. And then you buy the kit from the company. They send it to you. It's just a swab of your saliva. They'll do the genetic testing. They'll even do an analysis for you. And you get it sent to a trustworthy person's address somewhere, maybe even 2 levels deep, so that they can't really track it back to you. And then you get the information. And then if you had to, you could get an evaluation anonymously again by a molecular genetic doctor to understand the information. And then you can use that, but now it's privately just for you. No one else can know because they don't really know who you are. And then you could give bits of that information to your doctor. You wouldn't even have to give them the whole thing. You could say, well, I have the MTHFR gene, or I have these genes that are related to a liver that can't metabolize alcohol very well. To see you can protect your privacy. And you need to, because people under 40, they want your organs. If you're a good match, you talk about heart transplants, kidney transplants, if it's a big deal. Liver is better because you can get just part of a liver, but still, this is just going to get more intense. So your body parts should be precious to you. And if you give somebody your genetics, you're asking for it. It's an unfortunate reality. This may sound all pessimistic, but the leaders, I've said this before, leaders of the world, rich people of the world, they're not nice people, and they don't like us. They just don't. And you have to stop pretending that they do. They're not going to look out for us. The best we can get is they'll leave us alone. But this is a way for you to be left alone so that, my children and my grandchildren, and you can say I'm crazy, but go read about what's happened with the Chinese and what they're doing, and the hideous human crimes against this Chinese sect. These people are just put in prison and disappear in the night, and anyway, I don't want to get too far into my political soapbox, but so that's the main point. Genetics is valuable and important. And I'll make specific recommendations down the road. I've got to dive into this more to try to give people an idea of, okay, if you got $500 and you want to get some genetic testing, what should you do? And then you can take that recommendation, but you do it anonymously. And if you've already put your genes out there, well, just don't do it anymore. And just children, young adults, you're at the most risk. Do not let yourself be tested by your doctor or anyone else. You only do it anonymously if you're going to do it. And as simply as the way I said. Anyway, that's it. Another session of Dr. Debunk and a basic understanding of human genetics. Thanks for watching.